Hello, Honors Math 3. Well, it's new module Thursday. What we're starting today, this chapter 14, I'm calling it, was formerly module 8 in our MVP curriculum. We have decided that we're going to use textbook problems for the rest of the semester because the number of things you'd have to print for the module would have been crazy. So it was module 8 in our old curriculum. We're going to use our old pre-calc notes, which was chapter 14. So we're going to be up. The only thing you really need to print is the note sheets. You don't have to print them, but it would be nice if you had some notes to go off of. So the only thing you really have to print is these notes to walk through on the video. Everything else you can just use on your screen as a reference. All right, so we start chapter 14, getting ready for calculus next year, by finding limits of functions. It's a big calculus concept, a limit. What is a limit? Let's get comfortable with the idea for a second. Consider a shape, a polygon with n sides. If n is equal to 3, you know what a 3-sided polygon looks like. If n is equal to 4, you know what a 4-sided polygon looks like. A limit means this. Let's let n grow to 8. You know what an 8-sided polygon looks like. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's push the limit a bit. What if you had a 100-sided polygon? I certainly don't want to draw a 100-sided polygon, but you could imagine what it would look like. And so on, as n approaches infinity, what does a polygon with n sides look like? The notation we use for this thinking is a limit. What is the limit as n approaches infinity of a polygon? Obviously, as n approaches infinity, that polygon looks more and more and more like a circle. Is it actually a circle? No, but for all intents and purposes, as the number of sides increases, my polygon looks more and more and more like a circle. Now let's look at something that's familiar to us, a sequence. Here's a sequence, and what if a is equal a sub 1? For my term a sub 1, I plug in 1 and I get 1/2. For a sub 2, I plug in 2 and I get 2/3. ... For a sub 10, I'll plug in 10 to that pattern and get 10/11. Okay, let's find the limit as n gets larger and larger and larger and approaches infinity of that sequence. What is that sequence approaching, we say? What if I want the 1,000th term? That's 1,000 over 1,001. What if I want the millionth term? That would be 1,000,000 over 1,000,001. What is that sequence approaching as n approaches infinity? What is this getting closer and closer and closer to? The output is approaching 1. Is it equal to 1? No. The denominator is always bigger. But you notice how that little 1 in the denominator really carries very little weight. As my n gets bigger and bigger and bigger and bigger, my input into that sequence, that little tiny 1 in the denominator carries very little weight, and that limit is approximately equal to 1. What about this sequence? I'm going to ask you to jot down the first term, the 10th term, the 1,000th term. What is the limit as n approaches infinity of that sequence? I'll pause. Please notice as my input gets larger and larger and larger, my fraction value actually gets smaller and smaller and smaller, and that limit is equal to 0. Okay, so again, that's the concept of a limit. What value am I approaching? We typically talk about finding limits of functions in calculus. Consider the function, here's a little typo here, f of x is equal to 1 over x. Consider that function. Graph that function if you remember what it looks like. Okay, the notation we use for the function f of x equals 1 over x is, can you please find the limit of that function 1 over x as x approaches infinity? What value is that function approaching? As my x values get bigger and bigger and bigger and bigger, my function values, my outputs get smaller and smaller and smaller and smaller and are approaching 0. I would say that the function values approach 0 as x approaches infinity. Okay? You might say x will never actually reach infinity. I agree. As I get closer and closer and closer and closer to infinity, you might say my function values never actually hit 0. You're right, but they approach 0. So we do say the value of that limit is equal to 0. Can you please find the limit as x approaches negative infinity of that function? Or could you find the limit of that function as x approaches 2? Pause and evaluate those two limits. What are the function values approaching? As x approaches negative infinity, as my x values get smaller and smaller and smaller and smaller, please notice my function values are still approaching 0. As x values approach 2, what are my function values, my outputs approaching? As x values get closer and closer to 2, my function values, my outputs, are approaching what? My function values are approaching 2. I can just plug in 1 over 2, which is 1/2. What is the limit as x approaches 0 of this function? Pause and think about that for 1 second. What are my function values approaching as x gets closer and closer and closer to 0? You should notice this is a little confusing. As I approach 0 from the right, my function values are increasing without bound. But when I approach x equals 0 from the left, my function values are decreasing without bound to positive infinity on the right, to negative infinity on the left. This function actually does not exist. We abbreviate that as does not exist because the function values are not approaching a single value. My function values are not approaching a single value. Output. Okay, so the notation we're going to use for limits is this. We're going to find the limit of a function as x approaches some constant, some number. And we'll be able to evaluate that limit when my function values approach some number n. The limit, I'm going to pause and let you write this down. I read this as the limit of f of x as x approaches c is equal to n. Okay, important for limits. Remember that as x values get closer to c, but not even at c, as x values get closer to that number c, the corresponding value of x gets closer to n. And we'll see in a moment, the function does not even need to be defined at c because we're just getting closer and closer to c. You're going to need a graphing calculator. Please find your calculator. Okay, let's evaluate a limit using our calculator. Notice that this function f of x is not even defined at x equals 2. But that's okay. We're going to see what the function values approach as we get close to 2. And let's evaluate this limit. Please take a moment and plug this into y1. I like parentheses in my numerator and denominator. And we're going to find a table of values. Go ahead. Okay, pause often and plug this in. Go to second, table set, and set this up. Table start at 1, change in table 0.5, and go to second table and record your table values. Okay, notice this function is undefined at 2. That's okay. What are my function values getting closer to? You might be able to tell, but I'm going to take a little step in closer. So please plug this into your calculator and jot down those table values once again. Get a little closer. Please notice as my x values get closer to 2, even though we're undefined here, my outputs, my function values, are approaching, now we can tell, 5. And the value of that limit is 5. I'm going to hold off on this one for the sake of time, and I'll come back to that one in a moment. But let's look at a graph if we can and find limits off of a graph. I'm going to jot down a few limits, and you're going to we'll walk through these. Okay, let's read some limits of functions off of a graph. This complicated piecewise function is graphed up above. What are the function values approaching as x approaches 3? As x values get closer to 3, my function values, my outputs, are approaching 2. Try this one if you want to pause. As x values are approaching 2, my function values, my outputs, are approaching 1. Notice that we have that random point up there at x equals 2. That's okay. I'm not looking at where x is equal to 2. I'm looking at where my x values approach 2. My outputs are approaching 1. Pause if you would. What's the limit as x approaches 1? As x values approach 1, from the left, my function values are approaching 0. But from the right, my function values are approaching 1. That's confusing. It's not approaching the same value for those outputs. That's why that limit does not exist. Since that limit does not exist, since the outputs are approaching 2 different values, not a single value. Can you take a moment, if you would, and graph that function? My function is f of x equals cosine of x. Take a minute and pause and graph that. Okay, here's my cosine graph, and I want to evaluate the limit as x values approach pi of that function cosine of x. As x values get closer and closer and closer to pi, my function values, my outputs, are approaching -1. And that's the value of that limit. Okay, this is not an easy piecewise, well, I mean, it's a convenient piecewise function, but we haven't graphed piecewise in a while. Could you graph this piecewise function, and we'll use the graph to evaluate this limit. For this piece, for x values less than or equal to 2, I just want a standard parabola. And this was a closed circle, remember? At 2, 4, that's closed. And now graph that linear function to the right of 2, starting at 2 and going to the right. My linear function looks like this, open circle at that point with a slope of a positive 2. Notice as my x values approach 2 from the left and the right, my function values are approaching 2 different things. Unfortunately, after all that work, that limit does not exist. Okay, let's go back to some calculator practice. By the way, I was super impressed how most of you got through Module 7 with our sequences and worked through the quiz on Canvas. Thanks so much for practicing things at home. All of this will help you. And these limits will help you get ready for calculus next year. If you're in Calculus BC, this will be rushed through very quickly at the beginning of the year. So everything that you're doing right now is super important. Let's see, I'm going to come back to example 2, and I'm going to ask you to plug this function into y1, e to the x plus 2, and let's evaluate that limit. Take your time finding all this on your calculator, but we're going to get in close to x equals 0 in our table. Can you try this setup under table set and then jot down your table of values? Okay, I think I had to scroll down through my table a little bit so I could see what's happening when x equals 3. Actually, this function is defined when x is equal to 3, and those function values are approaching 3. I'm going to show my solution to example 6. Homework are textbook problems tonight, and I also uploaded my worked out solutions, so you can check your solutions. I'm going to work through quickly example 6 so you can check, but go ahead and get started. I plugged that whole function into y1. I like parentheses just to be safe. Now I want to get a table of values for x values approaching 3. I'm going to show you what I used, but you can play around with it a bit. Okay, this is a fun one. This is what I set up, and then I'm going to check my table values. Okay. Even though my function is undefined at 3, as my x values approach 3, my function values are approaching, rounded to 2 decimal places, 0.46. Thanks for watching. Have a great day. Bye-bye.